Okay, in order to identify the hot spots in chemistry, that is to identify where reactions are likely to occur, we are going to depend heavily on formal charges, identifying formal charges very heavily. All right, so what are formal charges? Well, in order to identify formal charges, we're going to have to determine the appropriate number of electrons for an atom. What is the appropriate number of electrons for an atom? That is essentially going to be the group number, okay? So remember this over here. We said draw the Lewis structure of a, for example, nitrogen atom. You see that's in group 5. Nitrogen's in group 5. So the appropriate number for nitrogen then would be 1, 2, 3, 4, 5, right? That's the appropriate number of an electron for an atom. Then we need to determine whether the atom has the appropriate number in its valence shell, okay? So if I'm looking at this structure right here, I would say, yeah, that atom has no formal charge at all because it's the appropriate number is 5 and it has 5 in its valence shell, okay? So formal charge then is going to be defined as the valence number minus all of the electrons in its valence shell. That is all of its unshared plus half of its shared. Okay? That's how we're going to calculate formal charge of an atom. All right? And we're going to do this extensively. So I'm afraid I overwrote something, but look behind here now. We are going to use formal charge easily and extensively to identify hotspots. Pretend you can read that. Pretend that's not overwritten, okay? And I'm going to emphasize that, say it again. We are going to use formal charge easily and extensively to identify hotspots. All right, so let's go and show how we might do this. Let me get rid of this here. Okay, so let's go back over here now and look at a question that might come up. All right, you know what I got to do here? Let me come down here. Let me get rid of this definition. Should put that definition in the wrong place. Let's put it over here. Let's say formal charge equals the valence number. That's the appropriate number minus all of the unshared electrons and half of the shared. Okay, so let's do the formal charge of this structure down here, and I'll stay in red. Let's come back up here. Okay, so let's do, the question is, consider the nitrogen atom below, that's this guy right here, right, you see it, in the structure below, and determine if it has a formal charge. Okay, so the formal charge in that nitrogen is going to be the valence number, so let's go over here. Nitrogen's group 5, right? So let's go back over here, and it's the valence number minus all of the unshared, and you see there are no unshared electrons here, no lone pairs of electrons, plus half of the shared, right? And how many are shared? 2, 4, 6, 8. Okay, so this means it is 5 minus 4, right? So the formal charge in this nitrogen is plus 1. Okay, and so we're going to write that as with the nitrogen here, and we're going to put a plus next to it. And that means that the formal charge on that nitrogen is plus 1. And this is magic. This is going to be, do I still have the green highlighter? I don't, do I? This is going to be the key for the chemical reaction that ammonium is likely to undergo.